Reality Check. Science meets myth.
What you're looking at, Sarah, is a replica of Tesla's electromechanical oscillator, a steam-powered electric generator patented by Nikola Tesla in 1893. It was meant to replace inefficient steam engines, but it's famous for a much darker legend. Later in life, Tesla claimed that a small version of this very oscillator caused an actual earthquake in New York City in 1898.
As an engineer, I respect Tesla, but let's look at the numbers. The oscillator relies on reciprocating linear motion instead of traditional rotary motion. Compressed air or steam is forced into an inlet, expanding into chambers and driving a piston back and forth rapidly. But Tesla claimed he could take a device just 7 inches long, weighing 1 or 2 pounds, and use it to destroy.
That's the genius of it. He wasn't relying on brute force. He was relying on the magic of resonance. He demonstrated that by matching the oscillator's mechanical frequency to the natural resonant frequency of structures, he could induce incredibly powerful vibration. The lore states that during his 1898 experiment, the machine locked onto the resonance frequency of his own building, and the shaking grew so violent he was forced to smash it with a sledgehammer to terminate the test just as the police arrived.
Let me break that down for you. Everything in the universe has a natural resonant frequency, a specific rhythm where it naturally likes to vibrate. Think of it like pushing a friend on a swing. If you push at the exact right moment over and over, they go higher and higher with barely any effort. Tesla's machine was basically playing the ultimate game of push the swing with thousands of tons of steel.
Exactly. But we aren't just taking his word for it. We are going to test this claim with our precision-engineered model skyscraper. I've wired the structural lattice with kinetic sensors. We're going to clamp our pneumatic oscillator to the primary load-bearing girder. Set the pressure to exactly 5 pounds per square inch and dial in the piston's oscillation to match the building's exact natural frequency.
If the legend holds true, this forgotten mechanical pulse will accumulate concentrated kinetic energy until the steel and glass literally liquefy and shake themselves apart.
Air pressure is locked at 5 pounds of pressure, engaging the inlet valve now.
The piston is moving. The internal air spring mechanism is regulating the oscillation period, keeping the frequency perfectly constant.
I'm dialing the frequency up, 2 Hz, 3 Hz. Wait, we are matching the structure's resonant frequency now. Look at the telemetry. The kinetic energy transfer is compounding exponentially.
Holy shattered glass, Batman. That tiny brass shaker is actually causing the steel frame to wobble like a giant metal noodle.
It's working. The structure is absorbing the mechanical vibrations. The glass is totally disintegrating.
The steel joints are failing. The kinetic load is exceeding the tensile strength of the lattice. The concentrated vibrations are liquefying the foundation under the resonance stress. We are looking at catastrophic structural failure. I'm activating the kill switch before it damages the bunker.
I told you, Sarah. The ancients, or in this case, a 19th century visionary, knew something we'd forgotten. Tesla really did build an earthquake machine.
I have to admit, Marcus, the math holds up. I didn't believe a 2-pound pocket device could output enough joules to do this. But by weaponizing the natural frequency, the energy accumulation was devastating. For destructive resonance, I'm giving Tesla's oscillator an absolute S-tier rating.
Well, there you have it, folks. Turns out, if you've got the right rhythm, you really can bring the house down. Literally. Make sure to like, subscribe, and join us next time on Relic Reality Check.